All right, so organic company exists in families known as homologous series, right? They exist as family known as homologous series, right? In a homologous series, the compounds have the same functional group. So in a homologous series, the compounds have the same functional group. So it's a group of organic compounds that have similar features and chemical properties due to them having the same functional group. So it's a group of organic compound with the same functional group. That is fine. Now, we're seeing the word functional group for the first time, so we need to be able to define what a functional group is. A functional group is a group of atoms or atom, right? So it's atom or atoms bonded together, and it is responsible for the chemical property of the organic compound. So the functional group is atoms or atoms responsible for the chemical properties of an organic compound. So it is the functional group that the molecule possess that's going to tell us how the molecule reacts. Clear?
Miss, can you repeat?
I said it's a functional group that's going to tell us how a molecule is going to react. All right. Now here we have, zoom in. All right, here we have a list of homologous series, their functional group and their general formula. These are very, very important. Now, your alkane comprises of, so the functional group, these are the drawing out of the functional group, but I'm also going to write the name of the functional group. So for alkane, right? Alkane functional group is carbon-carbon single bond. Right? So in an alkane, you will only see carbon single bonds, right? And the general formula is CnH2n plus 2. Alkene is carbon double bond. It can be written out like this, or we can write it in words. Carbon, carbon, double bond, that's the functional group. And the general formula for alkene is CnH2n. Then we have alkanol. Alkanol or alcohol, I like to call it alkanol because it helps when I'm writing the name of the compound. So alkanol have the OH, so it's a carbon that's bonded to OH, is a functional group, or you may see RCOH. The name of the functional group is called hydroxy. And the general formula for alcohol is CnH2n plus 1 OH. Then we have alkanoic acid or carboxylic acid. And the formula for that compound, the functional group is C double bond O. I don't think this is drawn properly, so I'm going to redraw it. C double bond O, OH, or we can write it out like this. And the name of the functional group is called carboxyl. And the general formula is CnH2n plus 1 COOH. No, as I said, I stick to the names alkane, alkene, alkanol, alkanoic acid. Why do I stick to it? Because it makes naming the alkane and the alkene and the alcohol and the alkanol and the alkanoic acid very easily. Now, each of these compounds start with ALK. Clear? Now, the ALK refers to the alk, right? Tells we're going to replace the alk with a prefix which tells us the number of carbon. So I'm going to introduce it to it. But any organic compound that ends in ane, we know it comes from the homologous series alkane. Any compound that ends with ene, we know it comes from alkene, homologous series. Any compounds that end in anol, we know it comes from the alkanol or the alcohol. Any compounds that end with anoic acid, we know that those compounds come from the homologous series alkanoic acid or carboxylic acid. Are we clear?
Yes, Miss.
Yes, Miss.
Now we are going to draw. We're going to recall the characteristics of homologous series. Now, this is where your text tells you something. And for those of us like myself, now, every member of a homologous series have the following characteristics or properties. All of them have the same general formula. So they all have the same general formula. They all have the same functional group, right? We do not use the word same for chemical property. We use the word similar chemical property. Or this and this similar chemical property is the same thing as can be prepared by similar method. So if you look in your concise, you're going to see them listing similar chemical property and they're going to list can be prepared by similar method. They're going to list them as two separate characteristics. However, when we are marking CXC, we take these two as the same. So if you write these two as separate property, you can only score 1 mark. They mean the same thing. Clear?
Yes, Miss.
There is a graduation of their physical properties such as melting point and boiling point as the number of carbon increases. That's another property. And the difference in molecular formula between one member and the next is CH2. So as we move from one member of the homologous series to the very next member, the molecular formula differs by CH2. So here I have 5 properties of the homologous series, right? You are required to memorize 4 of them. And remember, similar chemical property is the same as can be prepared by similar methods. Clear? All right, so we're going to name organic molecule. So remember that they all start with Al and they have some ending, which is ane, ene, anol, anoic acid. Right? So when we get an organic molecule and it's drawn out, right? And we're asked to name the molecule, you are going to look at the molecule and identify the functional group. So remember earlier, we said that if it is carbon-carbon single bond, what's the name of the, Carbon, if we look at the molecule and we're seeing carbon-carbon single bond as a functional group, what homologous series does that belong to?
Alkene.
Alkane.
And if we see a carbon-carbon double bond, what as a functional group, which homologous series does that belong to?
Alkene.
Alkene.
And we're seeing a carbon bonded with a OH, which homologous series does that belong to?
Alkene.
And we're seeing a carboxyl, which is a C double bond OH, which homologous series does that belong to?
Alkanoic.
Alkanoic acid.
Good. So when we identify the functional group, we're going to name the homologous series. Then the homologous series, the ALK, we are going to replace that with the prefix which indicates the number of carbon that we have. So here we have one carbon in the molecule, it's known as meth. If we have 2 carbon, it's eth. If we have 3 carbon, it's prop. If we have 4 carbon, we use the prefix but. If we have 5 carbon, we use pent. If we have 6 carbon, we use hex. Any question? No question? I'll give you a minute to take this off, and then we are going to name some organic compound. All right, let's look at this molecule. What functional group are we seeing?
Alkene.
That's
Carbon
homologous
double bond.
series. Listen, don't get me mad.
It's
Functional
carbon double
group
bond.
is now the
We're seeing a
carbon is
carbon double
bonded,
bond.
and the homologous series is the alkane, alkene, alkanal, or alkanoic acid. Do not make the mistake, because it comes on exam question. I marked this question in 2022, and half of the people who do the question, instead of naming the functional group, they were naming the homologous series. And then when they asked them to name the homologous series, they started doing foolishness, because the question wanted both. Let's go. The functional group is what? What is the functional group? Carbon-carbon double bond. Clear? So I look at the molecule and I'm seeing carbon single bond, but I also see a carbon double bond. So that means the functional group is carbon-carbon double bond. Which homologous series does that belong to?
Alkene.
Good. So I've identified the functional group, and so I've identified the homologous series. Then it says I must count the number of carbons that are in the compound and replace the alk with the prefix. So I'm counting the carbons. I get 1 carbon, 2 carbon, 3 carbon. Which prefix do we use for 3?
Pro.
So this is propene. Clear?
Yes.
So I am looking at this molecule and I'm looking for what the functional group is. What is the functional group in this compound here? It is going to C double bond OH. Clear? So the functional group is the carboxy. So carboxy belong to which homologous series?
Alkanoic.
Not just alkanoic, it's alkanoic acid. So it belongs to alkanoic acid. Then I'm counting the number of carbons. So I count 1, 2, 3, 4. When the number of carbon is 4, I am going to replace alk with but. Clear? So the name of this compound is butanoic acid. Clear? Let's go. Here we have carbon. What is the functional group?
It's an alkene.
Carbon single bond.
Carbon-carbon.
The functional group is carbon single bond. And because it is carbon single bond, it belongs to which homologous series?
Alkene.
Alkane.
in the alkane, we're going to replace it with the prefix that tells us the number of carbon. So we have 1 carbon, 2 carbon. Which prefix do we use for 2?
So ethane.
So it's ethane. Clear? So step 1 says, look at the molecule and identify the functional group. What is the functional group that we're seeing here?
Carboxyl.
Wow, very good. So because it's carboxyl, carboxyl belongs to which homologous series?
Alkanoic acid.
Then I'm going to replace the alkene alkanoic acid for the prefix that tells me how much carbon there is. So I need to count the carbon. 1, 2, 3, 4, 5, 6. How many is there? 6. So what's the name of this compound?
Hexanoic acid.
Acid.
Clear?
Yes, miss.
What is the functional group? Functional group.
Carbon single bond.
Look again.
Hydroxyl.
Hydroxyl. So this carbon has a OH, so it's hydroxyl. Hydroxyl belongs to which homologous series?
Alkanol.
Alkanol.
How many carbons is in this alkanol?
1.
So we're going to replace ALK with
Methanol.
meth. So it's methanol. Clear? All right, so this first one here, what is the, Malia, what is the functional group here for this one? Glenn, I don't get any work from you yet. Paul? So no, we're not do this today, you know. Let's go. Carbon, carbon, single bond. Good. So which homologous series is it?
Alkane.
So it's an alkane. How many carbons are in this alkane? 2. So it's ethane. Clear? All right, so let's look. Which homologous series is this compound right here? Which functional group, sorry? This is the hydroxy. So that means it belongs to which homologous series?
Alkanol.
Alkanol.
Alkanol. 1, 2, 3, 4. So 4, it's going to be butanol. Clear? Here, which homologous series this molecule is going to belong to and why? So I'm asking for homologous series and tell me why. Which homologous series this compound belong to?
Alkanoic acid.
Why?
Because of the double bond.
So because of the C double bond OH, because of the carboxyl, it belongs to alkanoic acid. How many carbons are in this alkanoic acid?
1.
So it's methanoic acid. Please remember the acid. Clear?
Yes, miss.
Miss Martin made a correction at B, please. And then here we have which, so the functional group is carbon, carbon, double bond, which homologous series?
Alkene.
How many carbons? 1, 2, 3, 4, 5. So it's,
Pentene.
then we have which homologous series this belong to and why?
Alkane is a single bond, so it is hexane.
All right, now we have 6. So 1, 2, 3, 4, 5, 6. So it's hexane. 1, 2. What's the name of this compound?
Ethanol.
So it's OH that we're seeing there as the homologous series. As the functional group, so it's going to belong to the alkanol, so it's ethanol.